Mr. Tesla, thank you for joining us today. Could you share with us a bit about your early life and what inspired you towards the journey of science and invention?
Certainly. I was born in Sevilla. From a young age, I was fascinated by the natural world and was determined to understand its mystery. My mother was an inventor of sort herself, despite never going to school, always tinkering and creating. I believe her influence played a significant role in shaping my curiosity and passion for invention.
Mr. Tesla, your resume looks quite impressive with contributions to alternating current and induction motor and even wireless communication. What inspired you to work on these projects?
When I was studying at Technical University at Graz, Austria, I was introduced to the Gravit dynamo. I was fascinated to see how it worked as a generator and when reversed, it turned into an electrical motor. Later at Budapest, I visualized the principle of rotating magnetic field, and with that, I started working for the induction motor.
Great inspirations. Could you share with us some of your later work?
I work on alternating current and describe how it is better than direct current for transmission over long distances. Apart from that, I developed numerous inventions ranging from the Tesla coil to wireless transmission of the energy. The Tesla coil, for example, has found application in radio technology, medical devices, and even entertainment through its use in Tesla experiment and demonstration. My work in wireless transmission laid the foundation for technologies such as radio and remote control systems. You might have also seen that I made a boat which was working remotely, and all of this has become integral parts of the modern life.
Okay, so have you published some work about the theories of alternating current?
Certainly, I have published several papers for my work. For example, a new system of alternate current motors and transformers. In this paper, I introduced the concept and practical application of alternating current motors and transformers, highlighting the advantages over the direct current systems. Apart from that, phenomena of alternating current of very high frequency is my another work in which I explored the behavior and properties of alternating currents of extremely high frequency. My research in this area contributed to the development of wireless communication and radio technology.
Your professional relationship with Thomas Edison has been widely discussed. Could you share your perspective on your collaboration and later rivalry with Edison and how it shaped your career?
My relationship with Thomas Edison was both complex and influential in shaping my career. In early stages of my journey, I had the honor of working for Edison, a renowned figure in the world of innovation. Our collaboration initially held promise, and I deeply respect his accomplishment and vision for the future of technology. However, as our professional relationship evolved, fundamental differences in our approaches to innovation became apparent. Edison favored direct current electricity, while I saw the potential of alternating current to change the way we harness and distribute electrical power. Although Edison's insistence on direct current electricity showcased a limited vision of electrical distribution. While DC was suitable for short distances, its inefficiency over longer lines was evident. The need for costly substations every few miles underscored its impracticality. Alternating current, with its ability for long distance transmission and efficient power distribution, represented the future of electrical engineering.
Can you elaborate a little on your work on wireless energy transmission and Warden Clough Tower project, because these were your failing endeavors?
An intriguing question indeed. One of the areas where my ideas have faced criticism is in the realm of wireless energy transmission, particularly the concept of transmitting power over long distances without the need of wires. However, challenges in efficiency and safety combined with the development of alternative transmission methods had limited its practicality. Moreover, my work on Warden Tower project. The tower was designed as a wireless transmission station and the laboratory to demonstrate the feasibility of transmitting messages and electrical power without wires over long distances. Unfortunately, financial constraint, and technological challenges like wireless power transmission over long distances presented significant technical hurdles at that time, including energy loss and safety concerns, combined with the outbreak of the World War I, shifted priorities towards the wartime technologies, diverting resources and attention away from civilian projects like War and Cliff.
Thank you for joining us today, Mr. Tesla. We will get back to you with the decision soon. Hello, Mr. Edison. So, Mr. Edison, I wanted to talk about your take on your dearest friend, Tesla. So, I wanted to ask, he's out there talking about wireless energy and all sorts of wild ideas. So, what do you think? Is he on to something or he is just zapping in the dark?
Thank you for having me. Well, where do I begin? Nikola Tesla undoubtedly was a brilliant mind. His contributions to the field of electrical engineering are undeniable. I witnessed his intellect firsthand when we met in 1884. I was in awe of his demeanor, intellect, and personality, and I offered him a job to work at the Edison Machine Works in Manhattan. Although the stint was short lived, I knew he was a gifted individual. For a brief time, I saw the man who would help me revolutionize the world. Revolutionized we did, however, in ways different from what I would have imagined. As I mentioned, Tesla's brilliance was undeniable. However, it became apparent that our visions for the future of electricity diverged significantly. My focus was on the practicality and safety of direct current systems, which I believed were better suited for widespread adoption and integration into society. Tesla, on the other hand, was an advocate for alternating current, arguing its superiority in terms of efficiency and transmission over long distances. Our differences in opinion eventually led to a rift between us. After just 6 months, he left the job I gave him to work on alternating current systems. Backed by George Westinghouse, he spent the rest of his life working on these technologies, while I aimed to perfect my trusted direct current approach. He had a sharp intellect, a talent for coming up with incredible concepts that stretched the bounds of what was previously believed to be feasible in the field of electricity. It is impossible to dispute his contributions to the advancement of electricity, and I have to concede that his alternating current motor was a brilliant idea. However, as Tesla's intellect flew to incredible heights, it frequently seemed to drift away into the mists of impracticality. The guy was known for his big ambitions and eccentric experiments, which occasionally bordered on the bizarre. Who in their right mind would consider erecting a tower to send wireless power all over the world? At times, it was as if he was more concerned with playing the role of a crazy scientist than with practical, real world uses for his discoveries. Let's not even get into his lack of business savvy. The man was a walking catastrophe when it came to handling his finances and obtaining funding for his initiatives. It's no surprise that he spent his last years in anonymity, experimenting with pigeons in a run-down New York City hotel room. In conclusion, while I cannot deny Nikola Tesla's brilliance, I must express reservations about recommending him for the research scientist position at Habib University. Tesla's approach towards science, though innovative, often veered into the realm of impracticality and even recklessness. His pursuit of grandiose ideas without due consideration for their practicality or safety could pose significant risks, especially in an academic environment where the well being of students and faculty must be paramount. Therefore, I would advise caution in considering him for this position.
Hello, Mr. Tesla. Thank you for joining us again. So, I wanted to tell you, while we really admire your ideas, we have decided not to offer you the position. As such, we have concerns about the practicality of your concepts, such as wireless energy transmission. Also, our current projects align more with the existing technologies, so we also encourage you to research independently. Thank you.